Good morning, student. Today we'll discuss the refraction through a prism. ABC is a prism in which A is angle of prism, and generally the angle of prism is 60 degree for equilateral or equilateral triangles, and in prism all three angles are 60 degree. This line we have, it is perpendicular on AB. This line is called normal, and this is an incident ray. If incident ray hits the prism here, this angle is called angle of incidence, PQ. P, you can say PQ or PQ, and then this ray bent towards the base of the prism. This is the refracted ray. This angle will be angle of refraction. Then on surface AC we will have another perpendicular normal, so such that it will make an angle of 90 degrees. So this is normal N2, and the ray will go this side. It will move away from the normal. Actually we are discussing only the refraction phenomenon. So this angle will be angle of emergence. Yes. And if we extend the incident ray in forward direction, now see here, if we extend this ray this side and this ray in the backward side, so this angle is called E or delta. This is called delta, and delta is called angle of deviation. Angle of deviation. Now which angle will be angle of deviation? PQ R S T U. So we can say S T U. Angle S T U, it is delta. And we have to derive an expression which will have a relation between delta I and R. Okay. Now see this angle. We can draw one more diagram for this. This angle is R1. Here also this angle is suppose R2. So wait, see here, if this is our prism, this is our prism, and this is the basic prism in which A is angle of prism, normal. The ray will come here. This ray is called incident ray. This angle you can extend it here. It will require later while deriving the derivation. Now this line will be also 90 degree, and this is angle of emergence. This is E. Now when we can say this angle is I, this is R1 and this is R2. So now we can extend it in this side. So when we extend this ray here, and this ray here, these two rays will meet at this point delta. This point is t, this point is t. So this angle will be what? This is I. So overall it will be I. This will be I minus R1. This is E. So this will be overall E. It will be E minus R2. And we have two normals. It will be like this: N1, N2, P, Q, R, S, T, and this ray you can extend, it will be STU. That angle is angle of deviation. Now what we can do? We can do that exterior angle. This one point we will write that exterior angle is this delta. In this triangle here, you see this triangle. It is Q, R, and T. So here we have delta, and this is I minus R1, and this is I minus R2. Q, T, R. So exterior angle is the sum of two interior angle. One hint we have: delta, it is equal to I minus R1 plus E minus R2. Equation 1. Now one more thing we have, this if you extend here, this is angle of prism A, and this angle is 90 degree, because this is also normal, this is also normal. So we can say it is N. Then we have two more things. In quadrilateral A plus N, A plus N, it is equal to 180 degree. Equation 2. Similarly, we have in this triangle QNR, in triangle QNR, R1 plus R2 plus N, R1 plus R2 plus N equal to 180 degree. The sum of three angles. The right hand side of these two equations are same. So from 2 and 3, we can say R1 plus R2 plus N, R1 plus R2 plus N equal to A plus N, and cut, we will get R1 plus R2 equal to A. Say the equation number 4. Then now very important equation is equation 1 and equation 2. In our prism, when we say that, when we are saying that this is angle I and this is delta and this is angle of emergence, so it is observed that when we increase I, delta also increases. But at one position the delta is minimum, and delta is minimum at that point R1 equal to R2 and I equal to E. If I equal to E and R1 equal to R2 equal to R, I equal to E and R1 equal to R2, this is the condition for the minimum deviation. Minimum deviation. So delta is what? I minus E, we wrote now, I minus E, I minus R1, I minus R1 plus E minus R2, or we can write I plus E minus R1 plus R2. Now if we put this condition here, so delta is called delta M, delta will become delta M, I plus E, it is both I minus both R. So delta M, it is equal to 2I minus 2R. We can say delta M plus 2R, it is equal to 2I, or what we can say, delta M plus 2R upon 2 equal to I. And this will be the equation number 5. Now what we can say for this equation, equation 4, what was the equation 4? Equation 4 was this. Equation 4 was this, R1 plus R2, this, because R1 plus R2 equal to A. So here for minimum deviation it will be also R, it will be also R. So equation 4, if we put R, equation 4 will become what? Equation 4 will be, equation 4 will be R1 plus R2 equal to A, R, A, it will be 2R equal to A. And this will be the equation 6. So now we have angle A, and we can say that R equal to A by 2, equation 7. Also in I also delta M plus 2R, here we can write A. So equation 5 also we can write delta M plus A by 2 equal to I. This we will keep because now we got I and R. So we have to put both these values in Snell's law, and we all know the Snell's law, I equal to R. So what is Snell's law? Snell's law, N equal to sine I by sine R, and I will be what? We have calculated I equal to sine delta M plus A by 2, and sine R is what? Sine R is A by 2. This is our prism formula, equation number 8. Because I put the value of I here, you can write put the value of I, put the values of I and R. So this is one relation between delta M and N. It is observed that if we plot a graph between I and delta, if we plot a graph between I and delta, the graph will be like this. On this axis we can take delta, here we will take I. So when we plot a graph between I versus delta, so here we can write angle of incidence, angle of incidence, and here we can write angle of deviation. So it will become, the angle will become, suppose it is 30 degree, 40 degree, 50 degree and 60 degree. This is I delta, and this is suppose 20 degree, 40 degree, 60 degree and 80 degree. So the graph will be like this. the graph will be like this. In this graph, if we increase I, delta decreases, and for particular value of I, delta is minimum. This is called the minimum, delta equal to delta M, and at this point I equal to E and R1 equal to R2 equal to R. And after that, if we increase the value of I, delta also increases. This angle is called minimum deviation. Delta M is called minimum deviation. For a very thin prism, if the prism is very, what is the formula of N? N equal to sine A plus delta M by 2 upon sine A by 2. Now for the thin, for thin prism, sine A plus delta M by 2 will become sine A plus delta M by 2 will become A plus delta M by 2. You know, sine theta equal to what? Theta. So it will become A plus M by 2, and sine A by 2 will become A by 2. Hence N will be A plus delta M by 2 upon A by 2, 2 cut, A plus delta M by A, it will be 1 plus delta M by A, or N minus 1 equal to delta M by A. This implies delta M, it is equal to A N minus 1. This is the formula for the thin prism. Then we can extend our derivation for the different numericals. So we will see numerical in our next class. Thank you. Read this